Textbook, we're going to shoot a projectile, which by the way is what we're going to start covering next week in physics. We're going to shoot a projectile into the air, all right, and it's going to leave the ground with an initial velocity of 288 feet per second. And by the end of this week, you should be able to convert that to meters per second. But I drew a picture to kind of get an idea. It says in the textbook that it shoots it straight up in the air. So it shouldn't be this picture, right? It should be a picture more like this. So it's just gonna launch up in the air, kind of like a model rocket at 288 feet per second. That's the initial velocity. It doesn't give us any other information. So we can only assume that when gravity hits this thing, what's gonna happen is it's gonna go up and then it's gonna come back down, okay? That's the only thing that we can assume is going to happen. So, with that being said, they want to know when will it reach 1,152 feet. And they give us an equation. Actually, the equation they gave us was this equation. It said that the displacement S is negative 16 times time, or t, squared plus 288t. Now, what I want to point out is right here, this is the actual formula that isn't listed in your textbook, but for one of your homework problems, they're going to give you an initial velocity that's different than 288t. So you're going to pretty much do that problem exactly like example number 8, except you need to figure out that the initial velocity is different and plug it into that equation. Okay? So this is important that you write all this down. So what do we know then? Well, we know that the initial position is 0 feet. It tells us that in the textbook. I didn't read it word for word, but it's something along these lines. A projectile is shot straight up in the air with an initial velocity of 288 feet from ground level. So that's 0 feet, all right? Well, we want to figure out when will it reach 1152, so we're looking to find when the displacement is at 1152. And so if we plug that into our equation, we should be able to solve this algebraically. We also know some other information too. We know that the initial velocity is 288, and as you may have already picked up on, and Mr. Adams already stated, the initial velocity gets plugged in here. So on that homework problem, I think one of your homework problems says the initial velocity is 256. Plug in 256 in that spot, and that should help you get the right answer. So if I move that 1158 over to the other side, well, actually, I'm going to leave the 1152 on one side, and I'm going to move the 16t, the negative 16t, and the 288 to the other side. In other words, I'm going to move these two things over to this side of the equal sign. That gives me 16t squared minus 288t plus 1152. Now what we really are looking for is the time t. And hey, I have a quadratic equation. So how can I solve my quadratic equation? Yeah, we could plug it in the calculator, we could plug it into the quadratic formula, we could factor it, we could complete the square if we had to. But I don't like this really big number of 1152. I really don't like 16 in front of the t squared. So let's hope and pray that the authors of the textbook rig the problem in a way that we can divide everything by 16. And guess what? You can. So everything divided by 16 reduces down to t squared minus 18 plus 72 equals 0. So our next step is to find two numbers that when I multiply them, I get positive 72, but when I add these same two numbers, I get negative 18. Does anybody have a clue what those two numbers are? We want to say, I think I heard it already, naturally we think of 7 and 8, but when you add those up, it's 17, right? But I thought I heard somebody say it over here. It's some, huh? Who said it? Well, what are the numbers? Say it. What were the numbers?
It was me.
Well, the two numbers are actually negative 6 and negative 12. So here's the thing. 6 times 12 is 72, But the reason we're making it negative 6 and negative 12 is I need this number to be negative and this number to be negative, because when I add them up, I want them to equal negative 18, right? I want these two numbers to add up to be negative 18. Well, if that's the case, I can get this quadratic equation by multiplying t minus 6 times t minus 12, which is, you write it out this way, we factored it. So then if I set both factors equal to 0 and solve, I get t equals positive 6 and t equals positive 12. Now what that means is that the projectile, I put the project, we've been doing a lot of projects lately, the projectile will be at 1,152 feet at 6 and 12 seconds after it launches. So I shoot this thing off, I count 6 seconds, 11:52. Now it's going to come all the way up. So here's what's happening. I got like a cannonball or whatever. I shoot it up in the air. 6 seconds later, it's at 11:52. Well, that doesn't mean that it stops. It keeps going forward. It keeps going higher and higher. Eventually, gravity takes its toll, and then it starts to come back down. After it comes back through, 12 seconds later, it is also at 11:52. And then it hits the ground. Okay? And that's what that means. Are there any questions whatsoever?